In this video, we're going to talk about how to find limits graphically and numerically. So let's start with an example. We want to sketch the graph of this function. Now notice this polynomial on top, factors. Let me get the pen up. So I can pull an x if I group the first two and the last two elements here. I can pull an x squared out of the first two, and I'm left with an x minus 2, plus I can pull a 3 out, and I'm left with an x minus 2 on top, and I have an x minus 2 in the bottom. And so I can pull the x minus 2 out of the two terms on top, and so I have x minus 2 times x squared plus 3, all divided by x minus 2. All right, now I have an x minus 2 on top and an x minus 2 on the bottom, and so those two will cancel. And so I'm left with just x squared plus 3. Now, this is only true if x is not equal to 2. Right? So this graph is going to look like the graph of this quadratic, x squared plus 2, everywhere except for when x equals 2. X squared plus 3. So that's x squared shifted up 3 units. 1, 2, 3. It's going to start here. 1, 2, 3, 4. And it's just going to have a hole when x equals 2. So when x equals 2, we would have plugged in and gotten 7. So we're going to get a little hole here. All right, so f isn't defined when x equals 2, but what happens as x gets closer and closer to 2? Well, these points are getting closer and closer on the y-axis to 7 in both directions. If I come in from the left, I'm getting closer and closer to 7. And again, if I come in from the right, I'm also getting closer and closer to 7. And that's the idea of a limit. Okay, another way to see that would be to plug some points in and evaluate f at those values. So let me erase to get some space. Whoops. What have I done? And let's try to plug in some values for x. You can do this on your calculator. So let's make a table, say x and f of x, and we want values close to 2. We're trying to figure out what happens as we get closer and closer to 2. So let's say I plug in 1.75, and if I plug that in, I'm going to get 6.0625. Now let's try plugging in 1.99, say. That gives me 6.9601. Now let's go a little bit closer with 1.999. That gives me 6.996. And I can come in from the other side. So if I plug in, say, let's start with 2.1, that's to the right of 2, and I plug that into f, and I get 7.004. I can plug in 2.01, that's a little bit closer to 2, and I get 7.0401. Now let's do one more, 2.001. And I get 7.004. And you can see that these values are getting closer and closer to 7. Now I see I've made an error here. When I plugged in 2.1, you should get 7.41. I apologize. And these values also are getting closer and closer to 7. All right. Oops. All right, so the official definition of the limit is this value L that the function f of x gets closer and closer to as x approaches c. What we write is that the limit as x approaches c of f of x is L. All right, so for example, let's evaluate the function f of x equal to the square root of x minus 2 minus the square root of 2, all divided by x at several points near 0, and then use that to estimate the limit of that function as x approaches 0. Okay, so let's do like we did on the last example and make a table. So I'm going to say x and f of x, and we're going to plug in values for x. Getting closer and closer to 0, and we want to come from both the left and the right. So let's start from the left, and let's plug in negative 0.01. Okay, so you're going to plug it into this function f. So get out your calculator and plug that in. You should get 0.354. All right, let's get a little closer. Let's plug in 0.001, negative 0.001. I got 0.3536. And how about negative 0.0001? I got 0.35356. We're not sure what happens at 0. Now let's come in from the other side. So let's do 0.0001, 0.001, and then 0.01. Okay, so starting from the far right, when I plug in 0.01, I get 0.35311, and then 0.35351, and then 0.35355. So what do you think? As we come in from the right and from the left, what does it look like f of x is approaching? It looks like the limit is approaching 0.353555. Okay, so what we'll say is the limit as x approaches 0 of f of x is 0.35355. Oops.